It is time for Tech Central, and by the way, in case you're an innovator, maybe you've dealt with something technology-wise, you've invented something, and maybe it's in the market, maybe it is not. Do let us know. We'd like to feature you right here on Tech Central as we continue to promote very innovative ideas done by Kenya, and well, let's see today what we have. And this morning, let me start first of all by introducing our guests. And I'll start with the lady who is on my immediate left, Liz Wanjiro. And welcome, good to have you.
Thank you.
Okay, we also have Cyrus Kiru. Welcome, good to have you. Last but not least, we have Caxton Kimiti.
Yeah, thank you.
Great to have you. All right, now, you have invented this robot, and that's what we're going to be talking about today. So if you get a close-up, you'll see the robot that we're talking about here. And before we get to what the robot can do and whether it's just a toy, would I be correct in assuming that you're all mechanical engineers? Kiru?
No, we are not mechanical engineers. We are taking mechatronics engineering.
Mechatronics engineering.
Mm-hmm.
All right. What is that?
It is simply a multidisciplinary, a combination of mechanical engineering, electrical engineering, IT, that is information technology, and computer science.
Okay. So all that is combined for you to come up with something like this, because of course I can see there's a lot of let me call it mechanics that has been involved. Yeah. There's also a lot of electrical engineering right there, and you've come up with that. So Caxton, how difficult is that? Because I mean, in the day and age I grew up, we used to call MPC maths people combination, people who did maths, physics and chemistry. Yeah. And mainly you'd be segmented to either do mechanical engineering, civil engineering, or electrical engineering. Now you've combined all. How difficult is that?
Well, we will say it's challenging, but achieving this is not that difficult, because every time you're coming up with something, whether mechanical, there will be a time you'll need to incorporate some electronics into it. Mm-hmm. So whoever came up with the STEM mechatronics and the course, so that there is a need to have a person who can be dynamic. You don't just limit yourself to one thing, because well, you can specialize, but if you have a person who knows how to deal with some electronics, some bit of mechanical, and you can program, you are about to encounter challenges and you'll be able to have a solution. So it's challenging, but it's a work in progress.
Okay, Cyrus, how long does the course take? Because I mean, if you do mechanical, you're looking at what, 3-4 years? Yeah. You do electrical, it's another 3-4 years. So does this take the full?
For mechatronics, it's 5 years, academic years. So you'll be in school for 5 academic years, full-time.
Okay.
Full-time, yeah.
Mm-hmm. All right, and Liz, your experience so far on mechatronics as a course?
Well, mechatronics is, say, a challenging course, especially being a lady. We are very few. Mm-hmm. But I would say that it is all in your mind. You simply set your mind in a particular direction, you can do it.
Why do you think ladies are few in mechatronics?
They probably fear the mechanical. It is assumed that the men have the physical energy. They are more stronger than the ladies. Mm-hmm. But I would say, provided you have your powerful tool, your mind, you can do it. You can do it. Yes.
Do you consider yourself, or have you been considered by others, a tomboy of sorts?
Well, not really. In the midst of my classmates, I'll at times be a tomboy, but I'm a lady.
You're a lady.
Yes.
Okay, fantastic. Okay, let's talk about this particular contraption. What is this?
Okay, basically, this robot, the theme behind this one, we looked at Mau Mau. How Mau Mau, yeah. Okay. You realize during the war, we had the people who were fighting, the men, they were in the forest, and we had the women who were going to take food and the rest, and they had to come go into the forest, and there are barriers, there are bandits and all that. So we designed this robot to be able to pick up something from a point, go avoid some obstacles, then take it to some collection point. So basically we used that theme. So what this does, we would pick maybe this bottle, it has water. It goes into the forest, which was a game field for that matter, then goes under some bridge, which represents barriers, maybe animals, you avoid them, and then go drop it somewhere else. Okay. Give it to the people.
All right, we'll come to the actual how that does, and I hope it can work, right?
Yeah. Okay.
And it can pick that bottle and do something with it. All right, we'll come to that, but why Mau Mau?
Okay, it's
it's a contest that is held yearly to promote robotics and innovation. It is organized by NACOSTI. So the theme for this year, it was Mau Mau. We tried to theme it according to African stuff. So the theme was Mau Mau. So we wanted it to relate, something you can relate to. So we are using the robot to navigate through the forest. So you're given a game field where there are obstacles, there are things to pick. So you have to avoid the obstacles, you have to follow tracks and go through caves until you reach the point that you deliver your equipment.
Okay, now Liz, maybe somewhere we should have started is defining a robot, because majority of us, when we imagine a robot, it's a human being made thing that is able to move, but this looks like a car. But also I know in South Africa, the southern part of Africa, they actually call traffic light robots. So what really is a robot?
Well, I would explain it in simple terms. For instance, this particular robot, there is the AGV, the
you know, some of us, you'll have to define some of this. The AGV, what is that?
Is it an AGV? Okay, it's an automated
Gadget.
Guided vehicle.
It's an automated guided vehicle.
Okay.
So you simply program it, and then okay, this particular one, there is the AGV part, the automated guided vehicle, and there is the arm, the robotic arm to pick the things. So you have combined it to simply form a vehicle that is performing, you know, a programmed vehicle that is performing a number of tasks, such as picking the food, you know, emptying it, taking it to the designated places. So I would simply define a robot as a programmed machine to do a particular
task. Okay, fine. Maybe we'll try and get a close-up of this particular AGV. Hey, I'm learning. AGV, automatic guided vehicle. Actually, my car is an automatic guided vehicle.
I know you drive. It's not.
But I am the one who guides it. But anyway, let's get to this. And can we see what it can do? Can we? And as we prepare to do that from home, we'd like to know, of course, if it's a hit or a miss. That's one of the things that we like to do on Tech Central. Whether it is something you can relate to, and whether you feel that it is something that is practical, or it is just a nice gadget that somebody has done for a project, and after they finish with the project, that'll be the end of it. But let's see how it works. So I'd like to know from you via Twitter whether it's a hit or a miss. But here we go, the AGV at work. Okay, so you've also, it's maybe able to pick that. Okay, now you had mentioned that it is maybe the director says maybe we do that again. Maybe we're not able to get a good shot of that, but would also like to see at home. Yeah, so this is the robotic arm, and it is a vehicle, so I guess it can move. But there you go, picks up the bottle and places it into the tray. I'm assuming from what you had described, this is now readiness for it to deliver.
Yeah.
Okay. Can it deliver?
No, currently it cannot, because the way we designed it, it's supposed to follow some track. We've used a sensor that is called a line tracker. So you have a white line, it follows, it tracks the line up to the destination. So for this particular setting, it is reading the whole, so it can
it will follow the whole table because it's all white. But now question, if that be the case, then that means then, especially given the theme that you've used, there would have to be somebody to draw the line for it to follow.
They would have to have someone to draw the line for.
Why do I need then to have the robot follow a line when I can draw the line myself or pick the thing and take it?
So what we have is just an initial program into robotics. So robotics, it's quite wide. This is just the starting, we can say the starting of robotics.
Okay.
We are just using line tracking, but you can use other types of sensing like image processing. So when you have image processing, you can guide the vehicle to go anywhere on its own, avoid anything on its own.
And those are the lines that possibly it follows. We can see one of it moving there. Okay, interesting. And when it follows those lines, what brain is giving it that ability to do that?
So it has a controller.
Okay.
So the controller holds the program. You have to program the sequence of the game field.
Okay.
So like for the lines, you have to count how many lines do I have to go to before I take a right turn, I take a left turn.
And now, to avoid it going in the wrong direction, should there be another white line that possibly you've not drawn? Is it using a remote control, or how does it know that this is your line?
No, the whole thing is automatic. We don't have access to it when it's on the game field. So if there was another line on the game field, it would count it as one of the lines that we had told it to count, so it will mess up the whole thing.
Okay.
But also, I think I can add, when it comes to obstacles, we also have a mechanism which helps us to avoid them. We have these sensors. I've heard you talk of sonar. The sonar, yeah, it is the same principle. It is an ultrasonic sensor. So sensing the distance between the object, the obstacle, and the robot, and it will stop once it encounters an obstacle.
All right. Liz, how long has it taken you to come up with this?
4 months.
4 months?
Yes.
Okay. And is it really hard work, or is it 4 months of maybe like pastime? You know, you just sit down and do an hour a day.
Well, it involves research, a lot of documentation, you know, the assembling of the equipment, the hardware, programming of the software, because you have to program the software so that you can feed it to the hardware, and then you'll direct it to move. So it has taken quite a number of days, say a number of months. 4 months is quite a long time. Yes, it involves a lot of research.
All right. And let's now talk about in terms of, because I know this is mainly for a project, and it is still at a conception level and stage. What other things do you envisage yourself doing once you've now got into robotics?
Right now, myself might get to Internet of Things. It's the next thing from robotics. So you get your things connected, your home connected to your car. Designing that and getting involved in Internet of Things.
Okay, how would that help me?
How would that help you? Okay, you have a fridge in your home. Take, for example, the fridge knows what is in your fridge. So if the fridge is connected to you, to your phone, to your car, when you're driving home, it will tell you, pass by this grocery, pick up this stuff. Pick this stuff. You don't have this stuff in the fridge, so pick it up as you go.
Isn't that possible to achieve through possibly just internet, or not the internet, but an online platform rather than a robot?
No, that will not be achieved by a robot. We are saying we are broad. We are actually, it's a club thing, so we have various departments involved. We have the mechanical, mechatronics, electronics, and IT. So when you talk of Internet of Things, we are now talking of how now we connect people, not using a robot, but using the basic appliances we have at home. Your phone, maybe, like you said, your fridge, everything that is connected to you. So whenever you are doing something, imagine even your car tells you when you don't have fuel. Now you have all the appliances telling you this is what you don't have, this is what you need. Imagine an electricity system that reminds you you need a bulb in your home. So you just buy. That's what we're saying.
So are all of you planning to go into the same thing, or are you going to maybe venture into different things eventually once you've finished what you're doing? Please.
Well, it being a multidisciplinary course, you can venture in whatsoever area you're interested in. You can say, I'll basically go into programming. No, I'll major more on that. But at the end of the day, you'll have to involve everything. Because for you to come up with such a thing, you have to involve all disciplines. But you can decide not to be it's called being a master of all. Well, being a master of one and not really.
And you major on one. What interest would you want to follow up? What would you want to do with your mechatronics?
Myself. I would go more into programming. And basically, well, I love the mechanical bit of it. Say, if for instance a car, automating a car, okay, nowadays we are using automated cars. Going into the mechanical bit of it and then applying the robotics that I have learned in school, I think I'd go into the automobile industry.
Okay.
Basically the mechanical and the automation part of it. Okay,
Caxton, what is it that you'd look at doing with your mechatronics once you're done?
Mostly I'm interested in design, like the whole design of this thing. I'm also interested in modeling. I like playing around with shapes and bringing up some maybe mechanisms that are improving on the current things that are there. So I see myself going into the design, mostly mechanical, a bit of electrical, Yeah.
Okay. Cyrus, what other things can a robot do, especially to improve our way of living? I know, for instance, there are those who probably use them for bomb disposal and stuff like that. What other things can robots do?
Yeah, you can also use them for rescue missions. We have underwater robots who can go to salvage ships which are sunk and such stuff. At home, you have people who are designing robots to take care of your kids, to keep company of your kids. So it's our idea.
But a robot, given the fact that it doesn't have a brain, it's programmed to do certain things. I mean, if you get it to a point where it's taking care of your children, isn't that risky?
Yeah, it's risky in one way, but it's not risky in the other way. This robot will never do anything apart from what you are told it to do. So it will always take care of your kid. The only risky part will come if there comes up an emergency, but you can also program it to alert you when there is an emergency.
Okay.
So you can program it to do a lot of things. Yeah.
Okay. I wonder how it would know an emergency, because some things, you know, are situational. It depends.
We have artificial intelligence currently. Like if you look at a company like Honda, they have created these robots that are even serving in hotels, and they are even courteous. They know how to say, hello sir, can I help you, this and that. So if we get into artificial intelligence, we are able to have robots that actually mimic the human mind. Only that now the intelligence is limited. I think currently we are
Liz, what is artificial intelligence?
Basically, artificial intelligence, it is trying to mimic a human being. We have a robot that is basically trying to mimic the brain of a human being. You've programmed it to act like a human being. Like for instance, the robot is talking about can say, hello sir, thank you. That's basically what a human person can do. It's simply, say we are trying to bring a robot to the place of a human being where it can relate with humans, as humans relate to each other.
All right, Kirkson, do you see a time and place where possibly the robot could replace the human being, especially at the place of work?
Okay, we don't say replacing, but the essence of technology is improving human life. For instance, we can say they will replace people in maybe hazardous situation, environment, for example, chemical fields and everything. Because when you send a robot there, it will be able to perform without much of, okay, we can have corrosion, but it is better than a human being affected. So what we are saying is we can use robotics to improve human life, because like we say, we are bettering life through technology.
Okay.
Yeah.
All right. Now, Cyrus, one of the things that you'll realize is that most of the robots that we use locally, and let me use an example of traffic lights and even the technology, because they are known as robots. They're programmed there to perform a certain task. We import most of them. Why can't we invent our own that we're able to use, that are contextualized and are able to be used for terrain?
Okay, as per now, the technology in the country does not allow us to produce our own robots, but with the learning that we are having right now, I think we are heading somewhere. Within 4 years to come, there will be people designing robots. Then the internet has opened up. Then you can link up with someone in China, help you design a robot. Link up with someone in Germany, help you to design a robot. So within time, we are able to design a robot.
Liz, what do you think is the challenge that you have when now you're doing what you need to do? What are some of the challenges you've had so far?
Limited information. When you're doing research, you may not have all the information you require to come up with such a thing. And say from the books available, but thank God for Google. No, Google has made life it has made life easy.
Yeah.
But I would say basically there's not enough information, and the machinery, the equipment to use. So you'll find you're limited because the machinery or the equipment you have to use cannot allow you to go to a certain level. Like for instance, there are things you will not do, like the artificial intelligence, without a number of equipment.
Okay. And maybe to throw the challenge to you, because you're upcoming and this is something that you're working on. We are a country that is more of consumers. We mostly consume our products rather than produce. Are we getting to a point where we can actually now become world leaders in terms of producing even technology and robotic, gadgets that can be used world over? Cyrus?
Yeah, I think we are coming to that place right now. with the opening up, you look at something like software development. We are reading software development, creating apps like M-Pesa. So the same thing, the same challenge has been put to engineers. So they are developing robots. You can design your own controllers, and with time, the limiting factor right now is the manufacturing. It's too expensive to manufacture something in Kenya. So with time, with manufacturing will be lower with time. You can.
What do you think drives that cost up, Cyrus, of manufacturing? That would, of course, now limit your ability to do what you need to do.
Okay, when it comes to, there are some particular, like for example for our robot, everything we have in the robot, we designed it. But when it comes to producing, we don't have people who have specialized like in creating the controller we have. So we have to go outside, maybe use China. Chinese have, have come up with so many industries in a cheap way to manufacture. Maybe if we had a way in the country where we'd have money focused on research, and I saw that with the Ministry for Higher Education. If we have money in research docket whereby they can fund people like us who have these ideas, we can bring up, small companies will grow with time, and that is how we develop the country with time.
And that particular gadget you're talking about, the controller, why can't we make it here?
We don't have the necessary machinery.
What
because precision, for example, to place we have very many components in the controller, very small. We cannot even produce microcontrollers. For example, when it comes to radios, they use ICs. The ICs we cannot be able to make in the country. That's a technology that is dated to 80s. So if we have such factories in Kenya that can be able to produce that, will be in a better position, because currently what we can only be able to do is produce the boards where we are going to place the components.
Okay,
so
and Liz, maybe to challenge you again, why can't we produce those ICs here? Why can't you be the guys who will invent and innovate a place where we can actually do that? Is it the material, the raw material that's lacking? What is not there?
I believe with five more groups of a team like this, we can do it. Because we'll say, when we'll continue being the kind of people who will say we cannot do this because of something else, then we'll get to the point where we can never do it, and we'll continue sourcing things from other countries. But I believe with more teams which are determined to get these things done, then we can do it.
Okay, Cyrus, I'm here to understand what is lacking, because yes, fine, we can't do it, but I don't understand. Is it the raw material that we don't have? Is it the brains that we don't have that know how to do it? What is lacking?
We have the brains, we have the materials, we can get the machinery. But the cost of production, the electricity you have to pay, it's very high. The cost of the people that you employ who have the brains, you have to pay them expensively, which is beyond your means. At the end of the day, you produce something that China produce at a lesser price, brings it to Kenya and sell it at a lower price than you did when you produced it.
So the main impediment here is cost. It's down to money. Does the government in any way supplement what you are doing by providing maybe some financial backup?
I understand there is a plan to do so, but this is being pushed on by, there is NACOSTI, it is the National Commission for Science and Technology. They're the ones actually who organized the robot contest. So they push for such funding, so we are waiting to see what happens.
Okay. And Liz, is this the only robot that you've done? Are there others?
No, there are many more. There are quite a number of them, but this was particularly for that contest, for the contest this year. But there are others. There was a robot for the contest last year, and there are others.
What did you make last year?
Well, for last year, it was a robot that was following, it had the same game field. It was following a number of things, avoiding obstacles, but that one, it had different materials to pick. This one, it's picking a cylindrical thing, and well, it could also pick a cuboid, but for the other one, it had different shapes.
Okay. All right, Cyrus, in terms of other robots, are you planning to do other maybe types of robots, and what would they be?
Yeah, we are now venturing into image processing. The next thing that we are doing will have image processing and voice recognition. So you can command your voice, you can command your robot using your voice. You can tell it, go pick that grass for me, bring it to me. So with the image processing, you need to know it's you who wants the grass, knows this is the grass, pick the grass, bring it to me.
Okay, so that's something that you're working on. How long should we give that? Because I'm sure that would be very convenient, especially in homes. You get home and you're tired and you want a cup of tea, like, bring that tea.
the first prototype will be out by the end of this year. So we are working on it. By 6 months we'll be done.
Okay. Caxton, your future, what do you see yourself doing?
One of the things we're doing, we are working with him on image processing and image processing and voice recognition. We also see this can also incorporated in other robots like the snake robot. For instance, when we had the issue, the building that collapsed in Huruma, you can send that snake robot. It resembles a snake. It can be able to go into those rambos and everything, detect whether there are people in there, send information back to the people, and we know exactly where the people are.
Okay.
Now,
Liz, looking at this contraption here, it is electrical, and from my little schooling in engineering, electricity and water don't go down very well. How would you send this if it rains?
Well, okay, when you're designing a particular robot, you have considered the environment. But in this game field, there was no the factor of rain, there was no the factor of water. But you will come to realize that all these cables, they are actually covered.
Okay.
All of them are covered. And, well, unless rust.
Okay.
Nothing else can really happen.
So even if I pour water in it right now, it's okay?
No. Not okay, but what you're saying.
Because I can see I have a glass of water here. You would have put it to the test, but anyway.
No, but what we did, we didn't cover it up because we wanted the people to see actually what you're doing. But it is supposed to be covered up, the electronics especially, and the cabling. But so, because we want you to see exactly what we are doing, we had to.
And I guess also for the fire, I mean, you could just put a body, something that is waterproof on top. All right, thank you very much, Liz Wanjiro Mwangi and Caxton Kimiti, Cyrus Kiru, for this wonderful technology that you're doing. And thank you for indulging us on, what do you call it, robotics? Robotics, yes. And there you go. That's our Tech Central. And that's where we're going to wind up this morning. But before we finish up, I'd just like to give you our poll results this morning. And the question that we asked was, are law enforcers finally dealing with hate mongers, alleged hate mongers, adequately? And so far we have 40% of you saying yes they are, and 60% saying no. Because of time, I'm not able to read your comments, but thank you so very much for staying with us right here on Morning Express. This is where we're going to wind up the show.